Hi, my name is Dave. I'm a product manager for Android Vitals. I'm excited to talk to you today about some of the changes we're making to Vitals to help you understand Play's new technical quality bar and about some tools to help you meet it. In this session, we'll cover the following topics. First, I'll remind you about Play's new technical quality bar, and then I'll introduce you to some new Vitals features to help you meet the quality bar. Then James will talk about some new API developments and do a deep dive into everyone's favorite topic, ANRs. He'll share some guidance on how to fix some of the top causes of ANRs and introduce you to some more new Vitals tools that will help you with these specific types of issues when you encounter them. Then we'll give you a very quick introduction to the newest Android Vitals metric. To start, let me remind you about Play's technical quality bar. Vitals has historically focused on showing you information to help you understand the type of experience your users are having with your app or game. Really, whether it's crashing or freezing, using crash and ANR rates. We recently changed our metrics to focus even more on user experience by creating user-perceived crash and ANR rates, which are the core Vitals metrics. This means background ANRs, like sometimes happen when users plug their phones in and all apps try to send usage data at once, don't count against you. We've kept the same thresholds for overall quality, but we have introduced a per-phone quality threshold, which is much more forgiving than the overall threshold. If the crash or ANR rate on a particular phone is higher than the per-phone threshold of 8%, users will see a warning in the store. With all these changes, it's more important than ever to have tools that can help you improve your technical quality. So, there are a number of new features I'm excited to tell you about today. First, ways to help you with debugging. And second, and perhaps most excitingly, in some cases we can even tell you what the fix for a particular issue is. To remind you about the tools Vitals offers for managing technical quality, we'll first start on the overview page. Here, you can see your user-perceived crash and ANR rates and view any alerts you may have. If you do have alerts or want to improve your crash or ANR rate, you can use the Crashes and ANRs page. In this page, we show you which specific crashes and ANRs are contributing most to your user-perceived crash or ANR rate. And you can drill down on each issue to see stack traces or thread dumps and various breakdowns by Android version or device type to give some context around the issue. One of the things you've asked us for is more help in actually fixing the issues. What should you do next? What the solution is? I'm pleased to announce that we've got a few projects that have recently launched and more in the pipeline to help you. Over the next few slides, I'll go into some more details about these. Most of these changes will be part of the Crashes ANRs page, which you'll need to visit to see them. First, we'll talk about features that help you debug. Some of Play's new products, Google Play Games on Windows and Play as you download, make your game run in a different way in order to reach a new audience. Sometimes, if there's an unexpected interaction, this can cause a crash. When a crash is caused by the Google Play Games on Windows platform or the Play as you download feature, which is very rare, we annotate it in Vitals so you know that this isn't something that you can take action on. You can hide these issues to clear them out of your issues list. Crashes that are reported in Vitals are also reported to the relevant Google teams, so they have the info to fix them. This is designed to help you focus on the issues where you can have the most impact. Next, we'll talk about an example of debugging help around ANRs. Later on in this talk, we'll discuss some of the common causes of ANRs and how to fix them in more detail, but I wanted to start with an example about unactionable ANRs, which is a common problem that many of you face. You may have noticed that some of your biggest ANR clusters are really hard to take action on. The thread dumps don't seem to show the problem. Here's what's happening. When an ANR is detected, the operating system is asked to capture a thread dump. But sometimes, by the time the thread dump is captured, the ANR is no longer happening. When this occurs, the thread dump that is captured shows either normal operation, if the ANR resolved between the time the ANR was detected and when the system got around to capturing the thread dump, or nothing, if the app or game was killed by the operating system. We have created an insight called main thread idle for issues where the thread dump hasn't captured the problem. Let's talk a little bit more about why this happens. Not capturing what we'll call the guilty thread dump is non-deterministic. ANRs are a bit squirrely, and sometimes the thread dump shows the guilty code, and sometimes it doesn't. When an ANR thread dump shows main thread idle, the actual underlying cause of the ANR could be many different things. Imagine you have 5 different errors that lead to ANRs in your game. Sometimes the operating system captures the guilty thread dump, and sometimes it captures normal operation. When it captures the guilty thread, Vitals will group it into one of 5 ANRs in your issues list, corresponding to the 5 underlying issues. But when the OS detects normal operation, it groups it into a 6th main thread idle ANR. This is because we use parts of the thread dump for grouping. Because there are 5 different underlying ANRs that are feeding into this 6th ANR with main thread idle, the main thread idle ANR will often be the biggest in your list. So, what to do about these main thread idle ANRs? Not capturing the guilty thread dump is non-deterministic, as I mentioned, so you can expect that the actual underlying problem will sometimes be captured properly, and the problem will be in your ANRs list. We suggest that you ignore ANRs with the main thread idle insight, and instead focus on fixing ANRs that do have useful thread dumps. That's why we've provided this annotation. By fixing other ANRs, you will reduce occurrences of main thread idle ANRs. This is because main thread idle ANRs are actually caused by other underlying ANRs which are captured as separate issues in your ANRs list. You may even want to hide main thread idle ANRs so they are not distracting in your issues list. We'll talk later about other ANR insights that will help you fix problems. And we have more debugging help we'll be adding over time. As a final example of how we can help you with debugging, we'll talk about debugging native memory errors. Native memory errors are a big source of native crashes, accounting for about 50% of occurrences. Memory errors are both bad for users and a security risk, and Vitals now helps to make it easier to find the root cause of native memory errors. Let me explain how. A major type of memory error is a used after free error. These can be difficult to track down because when a memory location is used after freeing, different things can happen. The app can crash. The app can do something funny if the memory contents have changed, but the memory isn't already reserved by the process that did the changing. Or the app can keep running fine if the memory contents are as they were left. This inconsistency makes it hard to track down and fix these issues. GWIP ASAN is a system that will consistently force crash your game at exactly the right spot when it detects an illegal memory access. It only does this a small fraction of the time, so it minimally affects your crash rate. When GWIP ASAN force crashes your game, the stack trace generated explains what the memory problem was, and extra stack traces for the memory allocation and deallocation may also be collected. All of this extra info is now displayed in the Vitals stack trace widget. And when we have stack traces with the GWIP ASAN information, we put them first in the stack trace viewer so you don't have to search to find them. This can make it much easier to track down and fix native memory errors. You can enable GWIP ASAN with a single line change to your manifest file. Follow the link on the screen for instructions and reduce your crash rate. Now, we'll talk about some features that will actually tell you how to fix the issues you're seeing. We're pretty excited about these. First, we have a project we call SDK Notes. Some of the crashes that occur in your app may be due to code that you don't control. Often these crashes happen in an SDK that you use. Play has a product called SDK Console where SDK developers can register their SDK and learn about crashes that are caused by their SDK. With SDK Notes, SDK developers can provide suggestions for how to fix crashes that are caused by their SDK. These are potential fixes for these issues written by the SDK developer themselves. If your game or app is affected by a crash caused by an SDK, and the SDK developer has provided a note, you'll see the note in the details page of the crash that you get to from the Crashes and ANRs page. These notes should help you quickly know what to do to fix the problem, whether that's updating the SDK to a newer version or changing the details of the integration. Not every SDK-related crash will have a note, but there will be more over time. And in the future, if your game has a crash that is related to an SDK that is registered with SDK Console, we'll allow you to report it to the SDK developer and send some more detailed stack trace information to help them investigate the issue. And hopefully, they'll write a note back telling you how to fix the problem. Second, we can tell you how to fix crashes when we can detect the problem in the stack trace. An example of this is that we can detect and tell you how to fix a crash that is caused by not updating the mutability of pending intents. Let's talk about this in some more detail. In November 2022, it became required to update the Android Target SDK to API level 31 for app updates. When this went into effect, many apps updated the Target SDK but didn't make the necessary code changes to support API level 31. Specifically, apps need to specify the mutability of each pending intent. If this is not specified, the app will crash on Android 12 or newer. This is actually accounting for a large fraction of crashes in the Android ecosystem right now. If Vitals detects a crash is caused by the pending intent missing mutability, we will show a message explaining the cause and tell you what you need to do to fix it. All of these features are designed to help you make the most of the Crashes and ANRs page, and really designed to help you improve your productivity. Helping you filter out ANRs that aren't actionable so you can spend your time looking at problems you can take action on, or getting extra information to make it easier and quicker to debug a native memory error. If you use another crash reporting SDK, such as Crashlytics, you may want to start visiting Vitals Crashes and ANRs page to see this extra information we now have available. I'll now hand over to James to talk about some more features.
Hello, my name's James and I'm the engineering manager for Android Vitals. I want to start by reminding you that for some of you power users, we have a Vitals API. You can get much of the same data we give you in the Vitals UI through this, and you can integrate it into your own internal dashboards in whatever way works for your workflow. There are hundreds of developers using the API to enhance their internal workflows. For example, as you can see, Gameloft has successfully used the API to enhance their internal dashboards and bring all their KPIs into one place to help their teams move faster. Now, speaking of faster, one thing we've heard from you for a long time is that you want to get Vitals data faster. Last year, we made daily Vitals crash and ANR data appear the next day. Now, we're pleased to announce that we will be bringing hourly crash rates and ANR rates to the API. You can query the API to find out your crash or ANR rate with hourly granularity. This can be helpful in detecting crash or ANR rate spikes due to a server-side change or a new rollout. You'll have to be clever about this though. Your hourly crash and ANR rates might have daily cycles based on time of day and local usage patterns in different parts of the world that you'll need to understand in order to interpret the hourly values. To find out more about our hourly vitals, please see our API documentation at the link on the screen. And if you have a game large enough to have meaningful hourly rates, you can start accessing them via the API in the next few weeks. We will let you know with a message on the Vitals overview page when Hourly Vitals is available to you. I want to come back now to the debug guidance insights that Dave mentioned and talk a little more about ANRs. Dave gave an example of the type of debug guidance we can give for ANRs, but I'm going to go through some of the common types of ANR in more detail and explain how to approach fixing them and demonstrate how we're going to use Vitals to show this advice to you right when you need it. But first, some basics. ANRs occur when the main thread, also called the UI thread of an Android app, is blocked for too long. To a user, this looks and feels like your game is frozen. Sometimes the ANR gets resolved on its own, sometimes the OS kills the game, and sometimes the user manually kills the game and hopefully reopens it. All Android developers need to be familiar with ANRs. They affect all apps and games and can be tricky to track down and especially to reproduce, as they can be affected by the state of the system overall. You can see on this slide some resources you can use to learn more about ANRs. Let's talk a little bit about why you should address ANRs. You want to keep your game's ANR rate below play's bad behaviour threshold, of course, but ANRs can make it hard for users to engage properly with your app, which can lead to reduced engagement and revenue. Fixing ANRs, conversely, can increase engagement and revenue by ensuring your users can use your game as it was designed to be used. You can see from this case study, which you can read on your own at the link provided, how OK Credit increased key business KPIs by reducing ANRs and enabling their users to have a better experience in their app. Okay, now let's start looking at some common types of ANR and how to address them. One thing to note is that for each ANR cause that we will discuss, Android Vitals will show an insight on the issue details page where we detect that particular ANR cause, and you'll only see these if we detect the particular problem. The insight will comprise a message in the Insights section and some annotations to the stack trace to show you where the problem is and provide some guidance. One common cause of ANRs are slow binder calls. Binder is Android's inter-process communication mechanism. Binder calls can be expensive and their duration can be unpredictable. In general, you should avoid making binder calls on the main thread. If you do need to make binder calls, you should instrument these calls to detect slowness that can result in ANRs. If your binder calls are causing ANRs, you can consider moving them to a different thread. In Vitals, we'll highlight the binder call that seems to be taking a long time. Up next, I/O in the main thread. Input-output operations can be very unpredictable and can block a thread for a long time. You should avoid I/O in the main thread at all costs. If you're seeing this type of error, you should refactor your code so I/O operations are done in a separate thread and not the main thread. I/O can typically be network or file operations, but can also be something seemingly innocuous like loading a class. In Vitals, as you can see, we highlight where I/O is taking place, and we let you know you should put I/O in a separate thread. Another cause of ANRs is the main thread being blocked trying to acquire a lock that's held by another thread, which may be doing I/O or a binder call. If this takes too long, an ANR is triggered. To avoid this, try to minimize the use of locks in the main thread. If you do need to use locks, ensure whoever holds the lock doesn't hold it for long. Some operations, like I/O or binder calls, have unpredictable durations, which makes it more likely for an ANR timeout to occur. These should be avoided while holding a lock. In Vitals, when the lock contention condition is detected, we highlight where the main thread is trying to acquire the lock, and we identify which thread is holding the lock and where the lock is being held, and we show these in the UI. Next is native lock contention. This happens when the main thread is blocked, waiting on a native synchronization routine like a mutex. For games, a mutex is usually used to wait for the CPU and GPU steps of frame rendering. In those cases, it's a good indication that the game's fidelity may have to be lowered on the affected device models. Native synchronization routines don't unfortunately provide details on the exact lock or where it's being held. You'll need to find the locked mutex in your source code, then locate other code locations where it's being acquired, and see if any of those can block the main thread. You can use Android Studio's profiler to detect lock contention of multiple threads frequently competing for the same lock. For this type of issue, Vitals shows where the native synchronization routine blocking the main thread is. Finally, as Dave mentioned earlier in the talk, we also have main thread idle ANRs, where the OS fails to capture the guilty thread dump. These types of ANR should be ignored, and you should focus on ANRs that do have useful thread dumps that show the problem, like the ones I've just been talking about. We will be showing insights and recommendations for all these types of ANRs in Android Vitals. When you look at an issues details page for an issue where we detect one of these causes, we'll show the message to help you understand the problem and hopefully have an idea of what to do next to solve the problem. Between the various different causes and situations, we'll be showing insights for around 20% of ANR clusters, which should help you address ANRs more productively. Some of these are available today, and others will become available over the next few weeks. Thanks for listening. I'll hand back to Dave to wrap up.
Thanks, James. Before we finish, I'd like to quickly touch on Play's quality bar one more time. We focused today on the existing metrics in that bar, user-perceived crash rate and user-perceived ANR rate. But there's a new metric that we're intending to add in, specifically for games, that looks at frame rate. If you're interested in learning more, please check out my other talk at the link on the screen. And if you're a game developer, you can also see these metrics in Vitals today. I hope you've enjoyed learning about what's new in Vitals and finding out a bit more about how to tackle ANRs. We hope these new tools make it easier to understand and fix stability issues and help you meet Play's new quality bar. To recap, Play's quality definition has changed. You can find out more about this in the keynote. Vitals Crashes and ANRs page is designed to help you understand which of your issues contributes to your user-perceived crash and ANR rate. We are adding tools to help you understand and fix issues more productively. These tools include debugging guidance for help finding the root cause of the issue and suggested fixes for when we have suggestions we think will save you a lot of time. Our API is a great way to include Vitals information in your existing monitoring systems. With hourly Vitals, you can monitor for issues in your crash and ANR rates with very low latency. And finally, Vitals has a new frame rate metric for games called slow sessions. You should watch the dedicated session at the link on the screen. Thanks for your time. We hope these changes help you fix issues more easily. Happy bug hunting.